So far, we've been creating objects, but we haven't had a great way to define their types. In this lesson, we're going to fix that by using interfaces and classes. First, we will start with interfaces. Interfaces provide us with the most pure form of abstraction. Now you might be asking yourself, what is abstraction? And to answer that question, let's look at an example that has nothing to do with programming. When you get in a car that is not your own, do you know how to drive it? In order to drive, do you need to know what type of engine the car has? Or for that matter, do you need to know any of what's under the hood in order to drive the car? You shouldn't need to know about any of the internal workings to drive the car, as most cars implement a standardized interface that allows you to drive. You're going to have your steering wheel, your pedal, and some other familiar components. Now maybe you happen to know what goes on when you press the gas pedal, but it's not a prerequisite to drive the car. You just need to know how to work with the interface provided to you. In programming, abstraction is the exact same concept. It means to hide the inner workings and provide an interface. We've been leveraging abstraction this entire time when we work with TS Node. Think about it. Do you really know what's going on behind the scenes? We have this idea that our code gets converted from TypeScript into JavaScript, and then Node runs that JavaScript code. But how does Node run the JavaScript code? How does actually running JavaScript code really tie into the physical components of your computer? Well, conveniently, we don't really need to know all the finer details of how things work. We just need to know how to use the interfaces provided to us, and those finer details can be abstracted away. In the scenario of TS Node, we know that we can run the TS Node command and specify which file we want to run, and it will run our file. Bringing it back to the code we write, we can create interfaces which will define what something should have without actually defining any of the concrete data or functionality associated with it. To demonstrate this, let's first create an object to store some information about myself. We'll say const myself equals, and we'll create an object. The first field we'll have is going to be first name. My first name is Blake. And then the second field we'll have is last name. My last name is Krupa. And then lastly, we might even want to define a full name, which is going to be a function. And in that function, we'll return the concatenation of my first name and my last name. So use template literals. And inside this function, the way we can access these other fields is through the this keyword. So we'll say this.firstName. And then we'll also interpolate this.last name. And for the sake of it, we'll print this to the console. If we hover back over our myself variable, VS Code will show us that TypeScript's actually done a pretty good job of inferring the type for us. We can see that the variable myself is an object with the property first name of type string, last name of type string, and full name, which is a function that returns a string. But allowing TypeScript to infer the type doesn't really give us much type safety. When we update our fields, we can update them freely, and TypeScript doesn't really care. It just assumes that's what you wanted to do, and it's now gone and updated the type definition to assume that's the correct property. So how can we guard against this while we're creating our objects? To do that, we can create an interface which will define the type for us. Here we'll say interface, and we'll say this is a person interface. And on our person objects, we need three properties. We need first name, which is of type string. We need last name, which is of type string. And we need full name, which is a function that returns a string. Now to use this type, we can simply say myself is of type person. And as soon as we do that, we can now see that we're leveraging type safety, and VS Code is showing me that I have an error. It's showing me that first name, incorrectly spelled, does not exist on the person object. VS Code is even giving me a suggestion. It's saying, did you mean to write first name, which is the correct spelling for the property? So we'll fix it. VS Code's no longer mad because TypeScript's no longer mad. And our code now has relevant type safety associated with this object. So let's go ahead and run this code and make sure everything's working as expected. And it is. We see that first name is Blake, last name is Krupa, And then full name is a function. We didn't invoke this function, so it's just saying that it's a function. If we wanted to actually see what the full name is, we'd have to invoke that function. We can go ahead and do that. We'll say console.log myself.fullname, just to verify that that function is working as well. And when we rerun this code, now we get the object printed, but then also we get the full name printed afterwards. So to recap the interface, what the interface allows us to do is it allows us to define a contract for what something should have. Notice the interface isn't defining any specific values. It's just saying person objects need to have a first name, and that first name needs to be of type string, a last name, that last name needs to be of type string, and a full name, which is a function that returns string. When we create our objects, if we violate any of these constraints, we'll get immediate feedback and TypeScript will fail to run because it does not fulfill the interface. Now, I don't want to confuse you too much, but we did mention that when we use functions and arrow functions, they interact with the this keyword a little bit different. So let's go ahead and change this to be an arrow function and see what happens. When we run the code this time, we'll actually notice that we get an error and it doesn't really work. It's because the arrow function interacts with the this keyword a bit differently. And in this scenario, we actually can't use the arrow function at all. We'll see other scenarios later where we actually need to use an arrow function instead of the function keyword. For now, we'll put this code back to how it was and be a regular function. When I was creating my person object, you might have noticed something that you thought was a mistake. You'll notice that my first name I capitalized, but my last name I didn't. And this was intentional because I now want to illustrate some of the functionality of classes. With a class, we can add some additional logic to ensure that even if I had provided the wrong casing, the class can actually fix it for me. So a class is going to be similar to an interface, but it goes kind of one step further, and rather than just defining what something should have, it can actually define implementation details for our objects as well. So I'll comment out my person interface, and this time we're going to create person as a class. We'll say class person, and the class is going to be similar. We'll say first name is going to be of type string. We'll say last name is also going to be of type string. And in the class, we'll actually create the full name function. We'll copy paste the code inside of it. And now when we create our objects using the class, every single object created will have the same full name function. So something else that a class needs is going to be a constructor. When we use the class to create objects, we'll be invoking the constructor and we can pass it information. So in our constructor, we're going to need a first name to be provided. That first name will be of type string, and we need a last name, which will also be of type string. Now inside the constructor, we're provided these parameters, but we need to assign them to the variables on the object itself. So to do this, we'll say this.firstName equals first name. And then we'll say this.lastName equals last name. And what we're effectively saying here is this.firstName will be referred to the variable on the object itself. And just first name is referring to the variable passed into the constructor function. Now to quickly try this out before we fix the casing on my last name, to create an instance of a class, we use the new keyword, we use the class name, and we pass in the parameters specified by our constructor, which is first name and last name. We see the parameters here. This is referring to those constructor parameters. So for first name, we'll say Blake. And for last name, once again, we'll say Krupa, and we'll leave the first letter lowercase. When we run this, everything works more or less the same way. We have a person object with a first name and a last name. It's not showing us the full name method on that object, but it does exist, and we can see it exists because when we invoke it, we get Blake Krupa all printed to the console. So let's go ahead and create a function now to fix the casing on our name. We'll call the function format name, that function will take in a name of type string. And in order to do this, we'll make it simple. We want to capitalize the first letter and cast all the rest of the letters to lowercase. So to get the name as all lowercase letters, we'll say const lower name equals name dot to lowercase. And then to get the first letter as a capital, we'll say const capital first letter is going to be name dot char at 0. This is basically saying the character at index 0, which will be the first letter of our string. And then we'll say to uppercase. We'll now return the formatted name. So we'll say return, and that's going to be the capital first letter plus all the other letters in the lowercase name, which will be lower name dot slice of 1. Now when we create an instance of our object, rather than just assigning first name to the property first name, we'll invoke our function format name and pass it in the parameter provided. And we'll do the same thing for last name. And this time when we run our code, we'll see that it properly fixed my name to have a capital letter, even though when I was creating the object, I mistakenly did a lowercase letter. What's cool about classes is when I define methods on the class, every instance of that class can reuse the same method. When I was using an interface, I couldn't define the method, and therefore when I was creating copies of that interface or objects to fulfill that interface, I had to define the method on every single one of those objects myself. So what we can do now is we can quickly create another person object. We'll say const other person, also of type person, equals new person. And for this person, we'll completely mess up their name. We'll say John and Smith, and then we'll print that person's full name to the console as well. And when we run this code, we'll see that John Smith was fixed. The first letter is capital, the rest are lowercase. The first letter is capital, the rest are lowercase. So when we used an interface, all we could say is what properties our object needed to have. But when we use a class, we can actually define implementation details, such as conversion of their first name when we're creating those objects, or assigning additional methods to each object without having to define it ourselves on every object individually. We do have a little bit of a problem though, and that's the fact that we can still manipulate this object and change the data on it. So we can really easily go in and we can just say other person first name equals, and we can remess this up. And now when we rerun this code, we'll see that John Smith no longer has a properly cased name. That's because we've gone in and we've overridden the first name with whatever we wanted it to, and we weren't forced to use the format name function to ensure it followed the correct conventions. To address this problem, we can use what's known as access modifiers. We'll come up to our first and last name and we'll make them private. And now that they're private, we can no longer directly access these properties. But what that allows us to do is it allows us to create getter and setter methods for accessing them and ensuring they're only accessed in the way we want them to be accessed. I don't feel like typing all of these out while I talk, so I went ahead and pasted them in here. We have our get first name method, which will return this first name. We have our set first name method, which will use the format name function when setting the first name. Then we also have a get last name and a set last name to ensure that we're only accessing the methods the way we want them to be accessed. Now when we come back down here, if we wanted to update the first name, we could say set first name. And to really show that it's working, I guess we can add a few extra letters in here just to show that it is updating the name. And when we run our code now, we can see that the name has been updated. And even though we had bad casing, it's still the first letter is capital and the rest of the letters are lowercase. Now with access modifiers, what the private modifier is going to do is it's going to make this only accessible from within the class. So here inside of get first name and set first name, we can still access the first name member. However, outside of the class, when we're interacting with the myself object, we cannot directly access those fields anymore. The rest of the methods, we did not specify an access modifier. However, this is implicitly the same as if we said a public access modifier, which means these methods are accessible outside. So the public access modifier will be the same as if we don't specify any modifier. Now you might still be a little bit confused, so let's kind of reiterate one more time what's going on. We defined a class person. This class person isn't actually any individual object specifically. Think of it more as a blueprint for creating objects. The class has a constructor, and to create an object from the class, we'll use the new keyword, which will invoke that constructor and create a new instance of that class. And then within the class, we have access modifiers so that we can show what we want to show and hide what we want to hide. And we can also create methods on the class, which will be associated to every single object without having to recreate those methods on each object individually, like we would have had to do when using an interface. If you're familiar with a strong object-oriented programming language, such as Java, this code might look very familiar to you. As everything in Java needs to be a class, it's very common in Java for classes to use access modifiers and getters and setters for interacting with those fields. I'll be completely honest though, in a lot of scenarios, it's really just overkill to have all of this overhead of the class and access modifiers and getters and setters. And there are some use cases, but it's going to be pretty uncommon for me to actually use classes in my code. I'm going to be using interfaces most of the time, and when I do use a class, I'll highlight the reason that I'm using a class.